Alright, so we might be a little fuzzy here, but we'll try to make it work. Okay, so this section is 3.3, log functions and their graphs. And, man, that's awful. Sorry, guys. Doing the best I can here. So we're going to talk about first how logarithms and exponentials are related. And basically, well, I'll show you rather than tell you. Alright, so I'm going to graph in blue, and I'm going to graph a log in red. Let's see if you notice what the relationship is. So remember we talked about our basic functions. One of our parent functions was e to the x, and it looked kind of like that, and it passed through the point 1. And then a log graph, the natural log, was also one of our basic functions. Looked like this. Also passed through the point 1, but on the x-axis, not on the y-axis. What do you notice about the graphs of those two? Yeah. They're inverses of each other. Right, exactly. If I put this line y equals x right through here, okay, they're reflections of each other over that line. Those are two inverse functions. So that's important. Okay, and this is true of any log and exponential that go together. But as far as the parent functions are concerned, e to the x and natural log x are inverses. Man, that's fuzzy. Sorry. So think about that for a second here. So the way that we do an inverse is if I had like y equals e to the x, and I wanted to calculate its inverse, what's the process that we took to do that before? Change the x and the y, right. So we'd switch that to x equals e to the y, and then try and solve that for y. And like we talked about yesterday, if you log both sides of this thing, then you can get rid of the base on the one side. So because it's e, if I do a natural log to each side, I get natural log x equals natural log e to the y. And then natural log of e to the y, there's this property that we use, we kind of mentioned yesterday, which we'll talk more about in the future, but we can bring the y down in front, and then we have y times the natural log of e. Okay, so here's a little property we're going to talk about a bit today, but see if you remember it. What is the natural log of e? It's just 1. Yeah, exactly. So we end up with the natural log of x equals y, or if we just switch that around, y equals natural log x. So we've shown that this is the inverse of that. Okay? So what that means is we can switch from one to the other then. Okay? So in general, and this is where this rule comes from that we talked a bit about yesterday, and this is for any log. So if I have y equals log base b of x, then I can switch that around so that x equals b to the y. And that's kind of my little conversion rule from one to the other. Okay, so that lets me do that. So if I have an equation written one way, to solve it, I might want to rewrite it a different way. So, and also, to evaluate some logs, it becomes a case where we might want to switch these things around too. So we'll do a few examples of this and see if you can just, to start with, just take the expression that I give you and take the log and see if you can rewrite it back into exponential form, just so we get used to this. So log base 2 of 8 is equal to 3. So what would that be then as an exponential? Yeah. Mm-hmm. Okay. So, and that should make sense, right? 2 to the third power is 8, right? So then log base 2 of 8 equals 3. So it's kind of unraveling this to write it that way. All right, so let's do one where I won't tell you what it's equal to and see if you can tell me by doing this kind of a trick as well. So let's do log base 3 of the square root of 3 equals x. And I want to figure out what value of x makes that true. And we might not be able to do it just yet in our head, so switching that thing to an exponential might be an easier way to help you see what x should be. So for this particular one then, what would be the exponential equation that goes with it? Yeah? Okay, so 3 to what power gives you the square root of 3? Yeah?
1/3.
No. You got the right idea, but I think you maybe just misspoke. Yeah? 1/2.
Oh, I got that.
Right? Because we said before a square root is a 1/2 power, right? So if it's 3 to the x, square root of 3, yeah, it should be 1/2. Okay, let's try another one. See if we can do this kind of the same idea here. Log base 5 of 1 over 25 equals x. So can we evaluate that log by switching it into an exponential as well? So somebody who has not spoken yet today, let's switch this one up. Yeah, Isaac. All right, 5 raised to the x equals 1/25. So 5 squared equals 25. So 5 to what power is 1/25 though? Yeah, -2, right. Okay, so what this allows you to do is to evaluate some logs. Now, do you have to do it this way? Not necessarily. There are some properties of logs that we will see that'll allow us to get through some of these problems as well. And that's what we want to do next is just kind of list out some properties. You've probably seen all of these before. It's just a matter of recharging your memory here. And then these will be things that we can use as well to help us evaluate some of this log stuff by hand. All right, so the first one, properties. All right, so the first one would be log base b of 1. So no matter what the base is, if you're doing the log of 1, what does the answer have to be every single time? 0. Yeah. Okay. Now, to prove that to you, why that's the case, I can switch this into an exponential and show you. Okay? If I have log base b of 1 equals 0, that would be b to the 0 equals 1 written as an exponential. Does that make sense? The exponential piece at least? Anything to the 0 is always 1, right? So no matter the base, raise it to the 0 power equals 1, so the log base b of 1 should equal 0. All right, this one's probably the most useful. Log base b of b, what should that be every time? 1. And again, I can prove it to you using an exponential. If I switch this one into an exponential, this would be b to the 1 equals b. All right, this base b raised to the first power equals this b, right? So anything to the first power equals itself, so the log base b of b, no matter what that number is, should equal 1. So that one will work too. Okay. Another one, log base b of b to the y. What do you suppose that one's going to be every single time? It's equal to y. Mm-hmm. All right, so if I switch this into an exponential to prove it, see if you can follow me here, okay? So this b right here is the base right here, b, raised to this y is equal to what's in the log, b to the y. So it's the case because b to the y equals b to the y. All right. In this one right here, we were really doing that same thing, weren't we? If this doesn't have a power written on it, what's it assumed to be? 1, right? So log base b of b to the 1 equals 1. That power should match what it's equal to. So if this was like squared or something, this would come out to 2. Okay. And then doing this same kind of thing, these two kind of go together. If I was doing log base b of b to the y, there's a property we talked about where you can take this y and bring it down in front. So y log base b of b. Okay? So in doing it this way, do you see how this still works out to equal y? Because what's the log base b of b? 1, right? So y times 1 still gets you y. Okay? So sometimes, rather than just going directly to this, you might want to think about bringing this down in front if it makes more sense to you, and then you can evaluate it doing kind of the same thing. Okay? So thinking about those properties, let's see if we can evaluate some of these other ones. And if you want to switch it into exponential like we did with those other ones, that's totally fine. Or if you'd rather just use one of the properties and do it that way, that's fine too. So let's see if we can do some evaluating here. All right, so we'll do another one. All right, so we've got 4 of them here for you. Log base 8 of 64, natural log of 1 over e, log of 0.01, and log base 2 of 1 over the square root of 2. Okay, so the first one. Is there a way that we could rewrite this first one so that it like matches one of those properties we just talked about and we can get the answer right away from that? Anybody have an idea? Yeah, go ahead. Oh, so you're going to do it to x and make it exponential? Sure, that works too. I was going to do it a different way for a second, though, just so people could see it, but you're absolutely right. You guys all see what I did there? I made 64 8 squared. Okay, so what property can I use now?
Log base b of b to the y equals y.
Right, so what should this one be? 2. Yeah. Okay. Or, like Josh was saying, if you want to switch it into an exponential, it would have been 8